Alright, here we go. 2010, number 4. Um, let's get us going here. Alright, straightforward question. Hopefully you see something like this and you go, alright, free points. 9 free points, hopefully. Well, not free, but you know what I mean. Okay. 4a. R is a region bounded by 2 square root of x. The horizontal line y equals 6 is this guy right here. The y-axis shown here. Find the area of R. Probably the easiest way to look at this is if I just take a strip and I can say, oh, that strip has thickness delta x. The height of it is just the top function minus the bottom function, and the top function is 6 minus the bottom function 2 square root of x. So that's the height of this strip, and then the width is delta x. So the area is simply the integral from 0 to 9, top function minus the bottom function, dx. And since this is no calculator, we have to do this by hand. So we got 6x minus, now remember x is x to the 1/2, so this is going to be 2x to the 3/2 divided by 3/2 from 0 to 9. So I'm going to simplify that and go 6x minus, multiply by the reciprocal, so that becomes 4/3, x to the 3/2 from 0 to 9, which if I plug 9 into here I get 6 times 9 minus 4/3 times 9 to the 3/2 minus 0, 0 minus 0, and that becomes 54 minus 4/3 times square root of 9 is 3 cubed is 27. 3 goes into there once, 3 goes in there 9, so it's 54 minus 36, which is in fact 18. There's A. B. Write but do not evaluate integral expression that gives the volume of the solid when R is rotated about the horizontal line y equals 7. So here's y equals 7, and it's going to rotate like that and look something like this. I'm probably off the screen here. There we go. Let's do it like this. And so this end's going to look like this. So you can kind of see what we're looking at here. Oops. So I look at a slice, and a slice right down the middle is going to be this washer shape right there. Okay, thickness is delta x, and I go from the top. I'm going to change colors and go to red, and so I've got delta v is pi times r squared minus r squared delta x. Big R is always from my axis of rotation all the way to the outside, so it'll be pi times capital R squared is the top minus the bottom, so it'll be 7 minus 2 square root of x squared minus, and then little r is, well, here I got lots of colors, green, which may or may not come up on your screen very clearly. That guy right there, 7 minus 6 squared. Get my colors back. Delta x. Okay, so that makes sense. Capital R squared minus little r squared, so then volume is, if I want to add all of those slices up, is pi times the integral from 0 to 9, 7 minus 2 square root of x squared minus 7 minus 6, you don't even have to subtract those if you don't want to, squared dx, because it says write but do not evaluate, so you can leave it at that and you're good 100% there. And then we look at part C. Region R, I'm going to go ahead and erase this now, is the base of a solid. For each y, where y is from 0 to 6, the cross section taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base. Write but don't evaluate the integral that gives the volume. So it's perpendicular to the y-axis and it's coming out of the screen. The height's 3 times the length of the base. So I'm going to try to draw this. So it's coming straight out of the screen. The height's 3 times the base. So if this is the base, this would be 3 times the base. So then my little rectangle here is coming out of the board or the screen like that. Okay? So the question is, how long is this? Okay, sorry about that. I don't know what I just said. I paused it. So we got to figure out what this base is. Now I know that what we really want to find is the volume of this rectangle that's shooting out of the screen. And I know the thickness is delta y, so I've got to write this in terms of y. So I know this is y equals 2 square root of x. So that's y over 2 is square root of x. So I know x is y squared over 4. So that's this distance. This is the x distance. In fact, here, let me accentuate that. This distance is x distance is y squared over 4. So the area of this rectangle is that base times the height. So the volume is that area times the thickness, delta y. Does that make sense? So we've got the volume, the piece of volume is going to be y squared over 4 times 3 times y squared over 4. That's the area, the shaded region here, times delta y. That's the volume of one slice. So then the volume of the whole thing is the integral from 0 all the way up to 6 of, what do we got here? 3 y to the 4th over 16 dy. Okay, does that make sense? There you have it. You don't have to evaluate it. It just says write it but don't evaluate once again. Okay, there you go.